All right, guys, welcome to a lesson on multiplying monomials. Today, what we're going to do is expand on our knowledge of monomial usage and learn more about them. Today, we're going to learn how to multiply them, and specifically, what we're going to be talking about are some exponent rules. All right, so let's get started. Before we go any further, though, I want to remind you guys that if you need the substitute to pause the video as you're going through this, please just ask him to do so you can get the notes down. This is also posted on my web page, and you can access it there as well if you've missed something and need to come back to it later. All right, so the first rule that we're going to talk about today is called the product rule. Now, the product rule says that if I have one monomial times another, and the base of those monomials are the same, so the a and the a here is the base, all right? If the base of those monomials are the same, then I can take the exponents and I can add them up, okay? So again, if I have two monomials that are of the same base, then I can take those monomials and add the exponents together to get combined one monomial. Okay, so the easiest example to show this is if I have a times a, all right, what do we have here? Well, really, there's no exponent written here, but there's really a 1, and there's a 1 on each of these. And we know that a times a is a squared, but what's really happening here is we're adding up 1 plus 1 to get our 2. Okay, so let's look at a couple of examples. If I have x to the third times x squared, I have the same monomial with the same base, and I can add these exponents together, so I get x to the 5th power. All right. Going down further, a couple more examples. If I have y to the 2nd power times y to the 13th power, again, they're the same base, so I can add these exponents together, so I get y to the 15th. All right. This next example is a little bit more involved, so I'm going to go through it a little bit more slowly. What I want to remind you of is the fact that if I'm multiplying things together, I can switch the order of them any which way I want. Okay. So I mean, I really could if I wanted to. I can put in multiplication symbols here and here, and I can move those things around. So the best way to move the things around in this problem is to put the kind of the same variables and the numbers together. So really, I could rewrite this problem as 3 times 2 times y to the 2nd power times y to the 3rd power. I mean, really, I could rewrite this in any method, any way that I want, but if you look at what I have now, it's really easy to see what I multiply together. 3 times 2 gives me 6, okay? And y squared and y to the 3rd, well, I can add those exponents to get y to the 5th power. So my final answer is y to the 5th. So here's a tip. Anytime you come across a problem that looks like this, what you're going to do is you are going to look at the numbers that are involved in the problem. And you're going to multiply those separately, and then you're going to go ahead and look at the variables that you have and multiply those together as well, and go right on down the line. All right, let's look at the last example here for this rule. And I'll give myself a little bit more space. Again, we have the same scenario where I could rewrite this problem any way that I want. So I'm going to write the 2 out front, 2 times x times y squared times y to the 4th. And again, this just allows me to see what I'm putting together. This is x here. So I got 2 times x times x gives me x squared, and y to the 2nd and y to the 4th gives me y to the 6th power. Okay, so this is my final answer. I am not going to require you to write it like this. However, I am just showing this to you so that you can visually see how you should think about multiplying these things together. All right, let's move on to the next rule. Power rule. Okay, this is when we have a monomial that we are taking to a power. Okay, so you're going to see parentheses just like this in a problem like this, and what you're going to do is you're going to multiply the exponents together. So you're going to keep the base the same. Base is still going to say a, and you're going to multiply the exponents. So let's look at an example. Here, I'm going to take 5 and 13 and multiply them together to get g to the 15th power. A couple more examples here. I don't have many examples for this one because it's a little bit easier than the stuff that we talked about last time. But again, here I have j to the 3rd power, and I'm taking this whole thing to the 2nd. So I'm going to multiply those together to get j to the 6th power. In this example here, I'm going to do the same exact thing. 4 times 3 gives me 12, so I get y to the 12th power. Okay, so going back up to the top here, if you have a monomial and there's parentheses around it and you're taking it to a power, you're going to multiply the exponents together. Okay, last thing we're going to talk about today is the power of a product rule. Okay, power of a product. This sounds like we're going to be taking a product of something and taking it to a power. So if we look, and I want you to look at this first. If we look, that's exactly what we have. We have a product, A times B, and we're taking that to a power. All right, so what this says is that this rule acts like the distributive property. It really does, but it's the distributive property for powers, meaning we're using multiplication here, just as if we're using the distributive property. So let's see what this looks like. Okay, if I have, and let me guess, maybe I'll erase this here. I'll go back to my pens. Okay, so if I have a product, okay, I have things multiplied together, and then I take that product and I take it to the power, then what I do is I take this n, whatever power this is, and I distribute this onto the exponents. So if I want to rewrite this in a different way, this is like saying I have a to the 1st times b to the 1st, and I'm putting that r in parentheses, and I'm taking it to the nth power. Okay, well, n times 1 is just n, and n times 1 is just n, so that's what's giving me this right here. Okay, so I guess a to the n, b to the n. All right, let's take a look at what this looks like in action here. All right, again, everything that does not have an exponent does really have a 1 on it. So here I have g to the 6 times 1 and t to the 6 times 1, with it, which is g to the 6th and t to the 6th. Okay, let's get some more complicated examples here. Let's just look at this example here, and I'll bring it back up. Same thing here, okay? There's really a 1 here, there's really a 1 here, and I'm going to distribute with multiplication onto everything on the inside, every single variable, okay? So in this case, I have x to the now 2 times 2, which gives me x to the 4th, and then y to the 2 times 1, which gives me y squared, and z to the 2 times 1, which gives me z squared. Okay, a couple more examples here. I'm going to extend the page, give me some more room, and I'm going to do it again, and I'll do this. Here we go. Okay, we're going to look at the left-hand side first. Okay, so this is the same exact problem. Now, in order to understand what to do first, you have to think of order of operations, where we look inside the parentheses first, okay? But if we do that, we realize there's nothing we can do here. We don't have any variables that are same, so we can't use our product rule where we're going to be adding exponents again. But from there, inside of parentheses, then we look to exponents, and we do have that here, which means that we are going to deal with this 2 after that, okay? So we're going to do this first, and we're going to do this second, okay? I hope that doesn't confuse you guys. So let me get rid of this here. And what we're going to do is distribute this 2 just like we did in all the other problems. So I got the 2 going over to the 1, and yes, there is a 3 to the 1st power here. There's a 1 here, a 1 here, and the m already has a 3 on it. And I'm going to distribute it to everything on the inside, okay? I forgot to draw a line here. And what I end up with is 2 times, and now on the inside I got 3 squared times t to the 3 times, or I'm sorry, the 2 times 2, which is 4, times r to the 1 times 2, which is 2, so r squared, s to the 1 times 2, which is 2, so s squared, and m to the 2 times 3, which is 6, so I got m to the 6th. And now I can do some more simplification here, because 3 squared is 3 times 3, which is 9, so I got really 2 times 9 times t to the fourth times r squared times s squared times m to the sixth power. Okay? And now here is where I'm going to stop for a second and point out a mistake that a lot of kids make. So pay attention to this. Okay? This is a monomial. Okay? If I'm going to multiply a number times a monomial, then I can only multiply the numbers together. That's it. Okay? What people want to do in this is they want to say, well, this looks just like the distributive property. So they start distributing 2 times 9, 2 times t, 2 times r. That is a big no-no. Don't do that, okay? What you are thinking of is a problem that looks like this. 2 times, let's just make it easy, 2 times t plus 5. And then you would distribute, because these are two terms, or this is a binomial, so you get 2t plus 10, okay? These are not the same, all right? The only thing that you're going to do here is multiply your numbers together. So we're going to get 2 times 9, which is 18, and then rewrite the rest of it. T to the fourth, r squared, s squared, and m to the sixth. All right, that one's done. That's the final answer. Let's move on to the last one here. This one's actually a little bit easier because if you know how to do the first part in this one, then you know how to do this entire problem here. Again, look inside parentheses. We don't have anything we can combine. So all we're going to do is distribute this 2 onto each exponent. Don't forget the number. So I got 6 squared times r to the 2 times 3, which is 6, and t to the 2 times 2, which is 4. So I end up with 6 squared, which is 36, r to the 6th, t to the 4th. Okay, that's it for today. Make sure that you guys write down the homework assignment, which is on the board behind my desk. You guys know where to find that. And I'm just going to leave you with this, okay? Thomas Jefferson once says, I'm a great believer in luck, all right, luck. And he said that I find that the harder I work, the more I have of it. Think of it, okay? Have a great day. We'll talk to you later.